morning, everyone. I'm Berkman Sahiner. I'm the program manager for the Precise AI program, and I will introduce myself a little bit more towards the beginning of my presentation at 9:50. But for now, let me thank all of you, in-person attendees, online attendees, for your interest, and the ARPA-H team for their dedication. Okay, so I'm thrilled to start with our first agenda item, a fireside chat with Dr. Susan Monares. Let me introduce her to those of you who may not be familiar with her. Dr. Monares is the Deputy Director for ARPA-H. She's a globally recognized leader with more than 20 years of experience in health innovation. Prior to her current role at ARPA-H, she led innovation at the Health Resource and Services Administration, focused on ethical use of AI/ML to support and improve health outcomes, novel approaches to addressing social determinants of health, expanding access to behavioral health, ending the opioid epidemic, addressing health equity gaps in maternal and infant mortality, and improving the country's organ donation and transplantation programs. Susan is a distinguished character serving the U.S. government, including her roles as the Assistant Director for National Health Security and International Affairs in the Office of Science and Technology Policy, and as the Director of Medical Preparedness Policy on the National Security Council. In both of these White House roles, she led efforts to enhance the nation's biomedical innovation capabilities. She served in many other leadership positions that are too numerous for me to list here, but I'll conclude with a bit of detail. Susan holds BS and doctorate degrees from the University of Wisconsin-Madison, so being here must feel like being at home for her today. So, Susan, please.
Thanks, Berkman. Thank you. First of all, we're going to have to shorten that bio. Second of all, it is so exciting to be back in Madison. I don't think I've been back in a number of years, very, very long time. And so when Berkman had the idea that we would launch something this amazing back in my home state, my backyard, I could not say no. I was so excited, and I'm just super excited to be here.
That was a trick to get you to the meeting.
Thanks. Love the tricks.
So let me start with a question that I think it's on many folks' minds. Why is AI so important for healthcare today?
Yeah, I mean, I think one of the things that many of us who have been working in healthcare for so long have observed is that the relative amount of resources that we're putting into healthcare. So, recent statistics, 4.5, maybe $5 trillion go into the health ecosystem. And they go into the health ecosystem across 4 primary quadrants, the way that we think about this. So patients, right? So patients are at the forefront of healthcare. That is why we have healthcare. Providers, so they are the interface with those patients to help at an individual or population wellness level. There's the payers, right? So somebody pays for this, whether it's a public payer like those in HHS or whether it's a private payer. Somebody is actually helping to make sure that the patients and the providers have a relationship, and there's a mechanism to pay for that. And then, of course, there's the infrastructure.
Could you hold this mic a little closer to trade off?
Yep, sorry, thank you. That's what I love about Madison. You guys are honest. I could, if I had this conversation anyplace else, I would have given that entire discourse, and no one would have ever said anything about it. So let me just make sure that I've addressed or I've shared so that you can hear it. So there's sort of the 4 quadrants of the healthcare ecosystem that we're thinking about: the patients, the providers, the payers, and of course the infrastructure. Why is AI so important? Because we have been investing for 10, 20, 30, 40 years to try to improve health outcomes for everyone. And honestly, how are we doing? Like, if you had to take a step back and you did a meta-analysis and you said, are patients getting healthier today than they were 5 or 10 or 15 or 20 years ago? Objectively speaking, from using data, which Berkman and I both love, not really. Right? Not really. Relative to other industrialized nations, our health span, our wealth span, our lifespans are not any better than they were. And in fact, they're getting worse in some cases for those populations that I've spent a lot of time on, they're falling behind. And it is sort of indefensible to be nearing the 21st and a half century and find that acceptable. Find that patients should not find that acceptable. Providers should not find that acceptable. The infrastructure, the places, the brick and mortar where we go and we get healthcare, it is not getting better, despite all these incredible investments. So where does AI come in? So AI has this value proposition to be an incredible transformer. On the patient side, if you are a patient and you are at home and you're wondering, whether for yourself or your family members, how am I doing? Am I well? Is my child well? Is my parent well? Right now, you can access information. You can go visit Dr. Google, which many of us do on a regular basis, and say, here's some symptoms that I'm having. Here's some symptoms that my child is having. Here's, something that my elderly parent is facing. And try to assemble enough of a picture of that wellness that you have a level of confidence that you don't have to go to that brick and mortar place to see your provider, or that you could take measures yourself to help address whether it's your own insights or for yourself or your family members or loved ones. But we don't need to do that anymore. So what AI allows us to do is to assemble this data, assemble this knowledge, collective experiences that have been contributed, that exist out there, and put it in the hands to empower patients to really start to think about their own wellness, the wellness of their children, the wellness of parents, wellness of family and loved ones. On the provider side, our providers, how many of you, raise your hand if you're a provider in this, if you actually see patients. It's hard work. It is so hard for you right now. And burnout is a real thing. And burnout is not just because you can't get to the golf course at 2 o'clock in the afternoon. It is because you are seeing patients in such compressed time horizons, trying to do so much for so many with so little resources. That is not fair. That is not where we want to be with our health ecosystem. Where we want to be is we want to empower providers to practice at the top of their licenses, to do the things that is so important to them. That is why you got into clinical care. It's not for revenue generation for the infrastructure or for any of those things. It is because you care about the people who are in front of you and you want to make them better. So AI is going to be incredibly valuable for you to, whether it's ambient documentation, so you don't have to sit in front of your computer and taking notes while your poor patient is standing behind you, hoping, crossing their fingers that they've told you the right things so that you can put the right things into the computer. And then somewhere the CPT code is added or an ICD-10 code is added and somebody gets paid for this and you get a referral. We need to fix that. We need to make you get back to the things that you love about your practice, that you want to be able to give back to your patients. On the provider side or on the payer side, get it, right? I mean, somebody's got to pay for this. There has to be margin, there has to be revenue. So how do you potentially offset costs related to fraud or other areas where you're trying to make the best decision as a payer, hopefully, and that you can use AI to help to increase your margin, so more of the revenue that's being generated can actually go back to the providers and into the patients. And then on the infrastructure side, we know that there is a huge potential cost associated with cybersecurity these days, right? I mean, so whether it's ransomware or whether it's compromised infrastructure because of cyber intrusions, we're launching a number of initiatives in ARPA-H that actually is going to help in an automated way, in a scalable way, to reduce the costs associated with the potential cyber intrusions. Okay, so why have I said all this? Poor Berkman, he's had to hear this so many times. I am so bullish, I'm so positive about the potential enhancements that AI will allow us to bring across those 4 quadrants. But we're here today because the risk and reward is still up in the air. Whether or not these AI tools are going to have the interface with our patients that are helpful, that they're productive, that they don't generate more risk, that they're user-friendly. I spent a lot of time looking at social determinants of health and disparities in healthcare and how it's promulgated. If we create tools and technologies that are only accessible if you're in Boston or San Francisco. And you're a patient population that's used to looking at your device and helping it with your just helping use it to make decision making. And we're leaving everyone else behind. That is a new social determinants of health. That is now saying that if you know how to use tech, you get to be healthier. If you don't, then you're left behind. Same on the provider side. If we create tools that we cannot ensure can be used by providers on the front lines in their incredibly busy days to help make decisions, unless they happen to be one of the providers or scientists who helped build the particular tool. We're not democratizing access to these incredible, valuable capabilities in a way that will help everybody, will help some and not all. And that is anathema to the ARPA-H mission. So AI is a reality. It will be implemented across all four of those quadrants. And the question for us, the question for Berkman is, can we do it safely, reliably, scalably, and democratize access so that we don't further exacerbate some of the health disparities that we're seeing in this country? It was a long-winded answer, Berkman, but as you know, I'm so passionate about this area.
Great to hear that. Yeah, great overview. So you mentioned about this huge potential for AI. What is ARPA-H doing to ensure that this potential is leveraged? And how do you see ARPA-H has changed things, let's say 5 years down the road about AI?
Well, the first thing that ARPA-H is doing is hiring brilliant people like you, Berkman. So thank you for joining us. The second thing we're doing is we're launching these crazy ambitious programs, like Berkman's going to talk to you about a little bit later. But we're making investments across those four quadrants already. One of the great things about ARPA-H, and sometimes DC doesn't get it right. Sometimes Congress doesn't get it right. Sometimes the executive branch doesn't get it right. But in the case of establishing ARPA-H, everyone got it right. We are not constrained with the same level of sort of guardrails that so many of our federal partners face in terms of what they can and cannot do and where they can and cannot spend their money. ARPA-H is disease agnostic. Our remit is to just create innovation across the health ecosystem. And we're not predefined, we don't have to spend money in, one area versus another area. Our job is to look for the biggest gaps and biggest challenges in the health ecosystem and then go after them and hire brilliant program managers and tell them they have 3 years to solve some of these big challenges. And then folks like Berkman and our other amazing program managers don't sleep for 3 years, but they do amazing things. And we're incredibly grateful. So we're already investing, and Berkman is actually at the lead for so many of these on one of the initiatives that we launched recently is the chatbot accuracy and reliability evaluation exploratory topic. And that is when I talked about, patients and their ability to trust AI-enabled tools that we know are going to be so critically important, or providers are using them, as a way to scale their ability to work with patients. Trust in those algorithms is so critically important. There is so much investment now being made in AI, in chatbots, and in patient-facing tools because the value proposition is extraordinary. You can't go to any conference with somebody else at 70 saying that where are we going to make money on AI, and it's in healthcare. But we know that some fraction of the tools that are being developed are not going to be what they say they are. They're going to be trained on data that is inappropriate, inaccurate, and misleading, or they're going to lead a patient down a path or a provider down a path that really we ought not to. So the care exploratory topic that Berkman was so critically important in launching is actually allowing us to create the ability to adjudicate and ensure that those are valuable. On the far end, when I talk about infrastructure, we've launched several very ambitious initiatives to reduce the vulnerabilities in cybersecurity using AI automation to be able to scan and look and get ahead of any of the healthcare cyber challenges that we know that are costly and highly impactful. What I love about what we're doing in cybersecurity is we're creating these tools that are fully democratized and accessible and affordable, whether you're a rural health clinic or an FQHC or a critical access hospital or, something that's operating on very thin margins and can't afford an IT staff where their, full-time job is just to look for cyber. We're actually creating these tools to be able to ensure that we're offsetting that. We're doing so much in this space, and I think we're here today because this is going to be one of our central and biggest initiatives in the AI space, ensuring that the algorithms being used are going to be what they need to be so that there is trust in AI, there's trust in these tools. And I think, because ARPA-H can invest in these high risk, high reward initiatives, we can do things that others would take, 5 years of meetings and councils and discussions and working groups and then we launch a program 5 years later. What Berkman's doing in launching a program, he didn't sleep for about 6 to 8 months, but we're launching it now and we're going to have impact next year or two.
Thank you, Susan. Do you have any questions for me?
I do have a question for you. So what makes you excited about this program and how do you think that we're actually going to launch something that will have an enduring and impactful influence, not just here in Madison, not just today, and not just over the next 3 years, but will forever change the way that we think about AI in healthcare?
Thank you. So to answer that, I'll give a little bit of my background and how we came to this program. I got my Ph.D. from the University of Michigan, a neighboring state to Wisconsin, and after in electrical engineering and computer science. And after that, I joined the radiology department at the same university, where I worked on designing tools to help radiologists interpret images more accurately and more efficiently. So I worked there for a number of years and then joined the FDA in 2009, where I worked in the Office of Science and Engineering Labs, which is like the research arm of CDRH. And there my research focused on imaging devices and machine learning devices, the problems and evaluating them. So I was also the coordinator for the AI program at OSO, where I helped identify gaps in the evaluation of AI-enabled devices, and then ways to fill these gaps with regulatory tools. Both of these experiences as a faculty member working on tools and as a part of the FDA working on evaluation gave me a good idea about how these devices work and what is further needed. And what I realized in time is that these systems are quite different from other types of products that are based on principles of biology or physics or chemistry, because they're so data dependent. And data is very fluid. It has this potential to evolve in time. And this led me to believe that we really need to monitor the performance of these devices, either in time or also among different clinical sites or among different distributions of patient populations. And what we see today is that the dominant paradigm is that one sort of assumes, both in the design and evaluation of these products, that the data is sort of stationary, that it is fixed in time. But we all know that clinics are dynamic environments that change. So I believe that having the ability, of course, not only to monitor the performance, but then to use the immense potential that we have with machine learning to sort of come up with ways to automatically identify ways to mitigate any problems with these changes in data, these data shifts, is I think something that's gonna help, first of all, the clinicians, because they will know how these systems are working in their clinic, so they will be able to trust them more. But also, of course, it will help patients by unleashing this potential, and it will help, I think, many other stakeholders by making these machine learning models really perform at their top level throughout their life cycle. So that's why I'm so excited about this program.
And I'm very excited about this program as well. I think we're wrapping up, but I just want to say one more thing for the participants in the room and those that are joining us online is this is such a great opportunity to walk out of the room with all your questions answered. Really making sure that everything that Berkman lays out over the course of the day and the interactions that you have the opportunity to engage in. This is a complex program because it's a complex problem. And we cannot do our job unless we get great performers willing to contribute. And so let's have a great discussion, great dialogue, ask a lot of questions, get a lot of answers, and then together we're going to do something amazing.
Thank you very much, Susan. Okay, we're right on time, so we'll go on to the next item on the agenda. I'm going to try to give you an overview of the program, and after I go through the program, there's going to be two invited talks, one from the NIH and one from the FDA, and then there's going to be a short coffee break. Okay, so we all know that AI usage in clinical decision support is increasing. For example, there has been a 10-fold increase in the number of FDA-cleared AI-enabled medical devices in the past 6 years. There's a 23% estimated annual revenue growth for AI in medical diagnostics, expected to reach $3.7 billion by 2028. This growth is currently led by devices and tools in radiology. Currently, about 75% of overall cleared AI-enabled devices are for radiology use cases, with an expected growth rate of 33% per year. Interestingly, in a study conducted by the American College of Radiology in 2020, so this is about 4 years ago, 33% of radiologists stated that they used AI. And of the 67% who said that they did not use AI, 20% said that they plan to purchase AI tools in the next 1 to 5 years. I do not know if these numbers have changed now, but my guess is that both numbers may have increased. So radiology is followed by cardiology in the percentage of FDA-cleared AI-enabled devices, and even a higher annual growth is expected in cardiovascular AI. I would also like to mention that there are many papers in the literature that suggest that standalone AI, that's AI by itself, can do better than clinicians in many tasks. Tasks such as detection of cancer on screening mammograms and classification of lung nodule as malignant or benign on chest CT exams. Next slide, please. Okay, so AI shows a lot of promise for diagnostic tasks, and the usage of AI-enabled tools and devices increasing. But how are these AI-enabled models doing in the clinical environment? We need to remember that AI models are typically developed in controlled and static environments, but real-world clinical environments are highly dynamic. In the life cycle of a predictive AI model for clinical use, a developer first collects data to design their AI model, and once the model has been developed, collects independent data to test and validate their model. The basis for this validation is a comparison of the AI model output to a manually extracted ground truth table,
For example, for disease detection, this ground truth may be whether the patient was actually diseased or not. Once the model has been tested, these evaluation results may be submitted to the FDA if the model is under FDA's jurisdiction, and then the device is deployed in clinic. However, the clinic is a highly dynamic environment and things change over time. These changes, sometimes called data shifts, are typically not detected or considered by current AI models in use. The changes may be due to, for example, a change in the patient population, a change in data acquisition. So on the upper right, I have a CT data that goes into an AI model. So maybe the scanner used to obtain that CT image has changed, changes in IT infrastructure, and many others. As a result, in time, the performance of the AI model degrades, increasing misdiagnosis by AI and causing mistrust by clinicians. Next slide, please. So this brings us to the what-if statement of this program. As you may know, most or all ARPA-H problems have these what-if statements that are visions for the program. What if AI models in healthcare auto-corrected to maintain peak model and clinician performance? Next slide, please. As I mentioned earlier, clinical AI model performance degrades over time, and this threatens patient safety. Temporal degradation of AI model performance has been documented by multiple studies and articles, as summarized on this slide. The paper that appears at the top left looked at a total of 32 data sets from 4 industries representing entirely different processes and target variables, looked at 4 different types of AI models for each data set. So there were 128 experiments that they conducted, and they observed temporal model degradation in 91% of these experiments. In the other paper on the top right, conducted by researchers from MIT and STAT, the authors traced the performance of algorithms past their early days of peak performance into the grinding years that follow, and found that the algorithms withered in the face of fast-moving clinical conditions. They stated that the problem is that the initial signs of dysfunction are often faint, and if you have to wait until an algorithm is broken for enough clinicians to notice, by then you lose the trust of the users who have decided to quietly ignore the model because they have got to know that it doesn't work as expected anymore. Next slide, please. Current post-market evaluation strategies are not timely or scalable. Currently, no clinical AI model receives regular testing and updating during clinical use to ensure the accuracy of the output. Despite the proliferation of medical AI approvals, little is known about their real-world usage. There are no requirements to monitor and update clinical AI models during clinical use due to lack of technical solutions. 84% of clinicians say safety and efficacy validation is an important attribute for validation, but currently, clinician intuition is the primary mechanism for detecting model degradation. And this is not the state we want to be in, because the primary priority of the clinician is patient health. It's not to track how the AI model is performing. Harm may have already taken place before degradation is detected by clinician's intuition. Finally, no clinically validated methods currently exist to monitor medical AI model performance as mandated by the 2023 executive order. The FDA is developing a regulatory path for post-market AI model updates, but current technologies from platform vendors do not include degradation detection or autocorrection capabilities. Again, in this program, we focus on AI-enabled decision support tools that are aimed to help clinicians make better decisions in their clinical workflow. We call these AI DSTs, decision support tools. As I mentioned earlier, there's an exponentially increasing number of FDA-cleared AI-enabled medical devices, and each of these devices are being deployed at an increasing number of clinical sites as AI gets more penetration. And for each of those clinics and AI-enabled tools, there are different factors that might affect the performance of the model, as we discussed previously, factors such as patient population, data acquisition, etc. All this results in a lot of different types of performance degradation that may need to be handled at different levels. For example, at the level of a single clinic, at the level of a health system, or at the level of all developer deployments. For example, an AI model's performance may degrade because of a shift in local patient demographics, and this requires a solution at the single clinic level. A model's performance degradation may result from a system-wide software update done at the healthcare system level. So this needs to be tackled at the health system level. Or the AI model may see a degradation because of new national guidelines. And this may require a solution from the developer that addresses all AI tools in the country that were affected. Since AI model degradation varies across clinical environments, automation is needed to maintain performance in all locations. In pre-market studies, one might observe a high performance in a controlled environment. However, when the device is put into clinical use, its performance will likely degrade differently across hundreds of clinical environments. The Precise AI program aims to develop tools that automatically detect degradation and suggest auto-updates to maintain performance at the right level from a single clinic to the national or global. In the current state of practice, post-market assessment is manual and sporadic, with no scalable method to detect or remedy performance degradation. This is mainly because there is currently no scalable method to establish what we call the correct AI output, which is the first step to measure the day-to-day performance of the AI model. If there's a data shift over time during clinical use and the performance degrades, the existence or extent of this degradation is unknown. And there is no mitigation techniques to address this model degradation. So when the performance degrades, it likely results in misdiagnosis and clinical mistrust and pushes the clinician to ignore the outputs of the AI model. The tools developed in Precise AI aim to fix this by first auto-extracting the ground truth label from clinical data using techniques that work independently of the institution that the AI model is deployed at. The AI model performance will be monitored using this label, and if there's a performance degradation, the root cause for that will be auto-identified, and self-correction measures will be automatically recommended. Finally, Precise AI aims to develop tools for actionable communication to all stakeholders. Here are the 5 technical areas, or TAs, of Precise AI. TA1 is surrogate ground truth label extraction. Here, performers will continuously gather the clinical test results, billing codes, and longitudinal records from multiple institutions to automatically estimate the true presence or absence of a condition, which we call a surrogate ground truth label, which will be used as a basis for performance evaluation by TA2 performance. TA2 is degradation detection and self-correction. Here, in TA 2.1, the performance will continuously compare surrogate ground truth to the AI output to detect changes in performance. Once a performance change has been detected, the root causes will be analyzed in TA 2.2. And in TA 2.3, the performance will develop automatic self-correction tools to mitigate the degraded model performance. For example, they could run several competing options that are continuously running and adapting in the background and update to the best performing of these competing AI models. TA3 is uncertainty quantification and communication to improve clinician performance. In this TA, the performance will communicate the uncertainty level of the AI model and other factors that may help the clinician correctly calibrate their trust in the AI model and demonstrate evidence of improved clinical decision-making due to uncertainty communication and bidirectional communication with the clinician. Underlying all these, we have a TA for core infrastructure, TA4, and a TA for independent verification and validation. To increase the breadth and generalizability of innovations, the performers will select clinical use cases from priority tracks. The 3 designated tracks in our program are X-ray imaging, CT imaging, and electronic health records to be used as inputs to the AI model. An example use case in the first track could be a computer-assisted triaging tool for prioritizing chest X-ray images based on suspected presence of pneumothorax. An example use case in the second track could be a clinical decision support tool to help clinicians detect acute appendicitis on thoracic CT images. And an example in the third track could be an AI model for early prediction of significant events in critical care based on electronic health records data. These are the designated tracks in the program, but you can also propose use cases that are outside of these tracks. However, if you propose a use case that's outside of these tracks, then we ask that you submit a proposal that addresses multiple TAs. And I will come back to this at the later slide. Next slide, please. Okay, now we will dive a little bit into each technical area in somewhat detail. I will describe the details of each TA and discuss some of the important metrics that we would like our performers to meet. TA1, as I mentioned, is surrogate ground truth label extraction. And as I discussed previously, a major reason why it is difficult to monitor the performance of AI models at scale is because the extraction of ground truth is a laborious process that requires a lot of human involvement. In current clinical practice, the AI gives an output. In the example in this slide, it classifies a patient based on the patient's X-ray images, pneumonia positive or negative. Let's say the patient in this case is classified by the model as pneumonia negative. That output then goes to the clinician, and the clinician will recommend next steps for case management. Depending on the information gathered, including maybe additional imaging exams, chest CT or lab tests, and clinical presentation, the patient may be managed as a pneumonia positive patient. So the AI and the clinical management do not agree. The problem is that in the current practice, the quote unquote ground truth is not extracted from the wealth of data that exists in the patient records. And there is no continuous comparison with the AI output to see whether the AI was correct for each case. And of course, there is no aggregation of that correctness over a set of patients to monitor the sensitivity and specificity of the model for this example. A potential performance degradation that may result from data shift is therefore not considered or detected. Precise AI aims to develop tools to automatically and scalably extract the surrogate ground truth label from the wealth of data that exists in patient records to establish a basis for continuously evaluating clinical AI model performance. Of course, the ground truth may be difficult to establish because it may not be known even after all tests for a given patient. That's why we ask the performers to extract the surrogate ground truth from patient data. For this pneumonia example, this data may include the patient's radiology reports, the patient's clinical indicators, interactions captured in other medical and clinical records, ICD codes, prescribed medication, and other data. Of course, there may be inconsistencies between these records, so it is up to the performers to come up with methods to best combine these sources to come up with the most accurate surrogate ground truth label. To achieve this, TA1 performers are expected to develop and optimize data extraction methods, including natural language processing methods to extract data from clinical reports and multimodal data integration, to consistently ingest data from different healthcare data infrastructures and information coding systems. I would also like to state that the representativeness of the overall data sets, as well as respect to different demographics in particular, is of paramount importance. Strong TA1 proposals will establish partnerships with hospitals and clinical sites that enables the program to evaluate AI-DST performance across a broad array of patients and environments through data collected in real-world conditions. TA1 proposals will demonstrate that enough number of cases can be collected through their partnerships with these sites from important demographic subgroups, for example, defined by ancestry, gender, age, geography, to make statistically meaningful comparisons of the performance of the AI-DST among these subgroups. The partnering hospitals or clinical sites should be varied in terms of their size, geographic location, and demographics they serve, so that potential AI-DST performance differences among these different sites can be measured, and any bias in AI model performance among different demographic groups can be measured and detected by TA2 performance. Here's a list of metrics for TA1 performance. I do not have time to go through all of the metrics, so I will focus on at most 3 for each TA. But please do ask questions, and we will try to clarify for you what we have in mind and what we have already described in our solicitation. In phase 1, TA1 performers are expected to work with at least 3 clinical sites for surrogate ground truth table extraction, and this increases to 5 sites in phase 2 and 8 sites in phase 3. These sites should ideally include different electronics health records infrastructures so that TA1 performance can demonstrate the scalability of their approach to different clinical sites. As I mentioned earlier, unbiased data collection is very important, and the proposer should describe how the clinical site portfolio allows for unbiased data collection in terms of patient demographics. Now, a TA1 performer should team up with a TA2 performer so that they extract the ground truth label for the use cases that the TA2 performer brings to the program. We'll go into that in next couple of slides. But for a given use case, we understand that data may not be available for some patients to extract surrogate ground truth label for all cases. For example, a patient may move from the area of a healthcare system to another area, or a patient may fail to follow up to enable the collection of enough data to allow an estimation of the surrogate ground truth label. So the target in phase 1 is to have the ability to extract a surrogate ground truth label for 60% of patients, increasing to 90% at the end of phase 3. And the fourth metric that you see in this list is about the agreement of the automated surrogate ground truth method and the manual ground truth that is typically used in retrospective studies. Of course, the manual ground truth label cannot be obtained for all cases that come into a clinical site. That's why the manual ground truth is not scalable. So we would like the performers to measure this based on a random subset of patient cases for each use case and each clinical site. And we would like to see an agreement of over 85% at the end of phase 1, increasing to 90% at the end of phase 2. And when you define an agreement, you need to define it in a manner that makes sense for a use case. For example, for a binary classification problem, the agreement could be the average of positive percent agreement and negative percent agreement, so calculated separately for the positive and negative patients or cases, and then averaged. So now we move on to TA2. The goal of TA2 is to automatically detect, identify root causes for, and correct AI-DST degradation to maintain peak performance. In the current state of practice, there is no standard method to quickly and accurately detect or correct performance degradation post-market. In this example, shown at the top, a model may be working okay when it's first introduced into the market. Before a data shift, this figure on the top left shows that shows the distribution of disease and undiseased cases and the decision boundary, which pretty accurately separates the two classes. However, after a data shift on the top right, due to changes in clinical settings, the distribution of the positive cases has changed, and in this example, the decision boundary does not accurately classify disease-positive cases anymore. Precise AI will first develop an alert in this case, then identify the root cause, in this example, that the distribution of disease-positive cases has changed, and then recommend an action for mitigation. In this example, a new decision boundary that brings back the sensitivity to the non-degraded level. Okay, here are the metrics for TA2. Again, I have time to go through only 3 of these. The first is the breadth of clinical use cases. We would like each TA2 performer to come up with AI DSDs with 2 clinical use cases in phase 1. Please note that the purpose of the program is not to design the AI models for these use cases. The performance should already have these AI models that have been developed in the past. These may be models that were trained, tested, and published on before by the proposers, or they may be models that are actually in clinical use today if they are under FDA's jurisdiction with FDA authorization. So we would like TA2 performers to share at least the executable code for these models with TA1 performers so that TA1 performers can run the models in the clinical environment and return the AI model output to the TA2 performance. We would like TA2 performers to provide correct degradation alerts following a 5% degradation in AI-DSD model performance in 70% of degradation events in phase 1, increasing to 90% in phase 3. This should happen at a clinically relevant false alarm rate and time to correct alarm to be specified by the performer in their proposal. We understand that these degradations may not happen very frequently in a clinical environment. To obtain precise numbers for these metric values, we therefore give the proposers the chance to and encourage them to evaluate these in simulation environments using simulation tools that TA2 performers are expected to develop, as described in the solicitation document. But we would like the performers to also apply these degradation detection techniques to real data as much as they can. TA2 proposers should also describe plans to incorporate features that account for variations among patient subpopulations in their degradation detection, root cause analysis, and model self-correction tools. This will ensure that the AI tools are designed to continuously measure AI model performance degradation across different subpopulations and suggest corresponding corrections. This will also ensure that changes leading to different degrees of performance degradation for different subpopulations, i.e. changes that lead to a bias among subpopulations, are detected and mitigated quickly and effectively. This shows an example by what I meant by a certain percentage reduction of false negatives at a given specificity. Let's say that with the degraded model, with a specificity of 90% or a false positive rate of 10%, we have 10% false negatives. As shown here on the right in blue, Fn equals 10%. With the improved model, a 50% improvement in false negatives will mean that the false negatives will drop from 10% to 5%. So we will be at this point shown with the orange dot on the curve labeled as model with AI self-correction. TA3 is uncertainty quantification and improvement of clinician performance with the developed tools. In the current state of practice, medical AI-enabled decision support tools fail to convey model certainty in a meaningful or actionable way, resulting in inappropriate level of trust. In addition, the communication between the AI model and the clinician is unidirectional, which does not foster clinician trust. Precise AI will develop tools to quantify model uncertainty, and develop tools to convey that uncertainty and other complementary measures to clinicians in an actionable way. Importantly, the communication will be bidirectional, allowing the clinician to probe the model, resulting in improved clinical decision-making due to how model uncertainty and other components are conveyed to the clinician. And when we talk about uncertainty quantification, we need to be cognizant that there are different types of uncertainty. For example, the AI model may say that the patient has 60% chance of disease based on the AI model input. Alternatively, it may say that the patient has 60% chance of disease and the 95% confidence interval for disease is 55 to 65%. Or it may say something like the lesion volume is 1 plus minus 0.1 centimeter cubed. So this may depend on the type of uncertainty that you're looking at. For example, the aleatoric uncertainty that stems from the inherent stochasticity and variability in the data that cannot be reduced no matter how many more data samples are added to the training pool, or epistemic uncertainty that arises from a fundamental lack of information. For example, in the two-class classification problem shown at the bottom left, where a classifier is trying to distinguish between the red and blue cases and has come up with the decision boundaries shown in black, data points shown in yellow may get the same classifier output because they are at about the same distance from the decision boundary. But the 95% confidence interval may be much narrower around the point that's in the middle, that's in a data-rich portion of the decision space, compared to the other point on the left, which is in a data-poor portion of the data space, which is away from most of the available data. Okay, here are the metrics for TA3. Again, I have time to go through 3 of these. The first metric is related to the performance of the uncertainty estimation method by itself. To test the technical performance of this, we would like to perform what is sometimes called reject option classification. We would like the performance to use the calibrated classification scores as well as the confidence intervals for those scores to abstain from making a prediction for a given percentage of patient cases. We understand that this percentage may be application dependent, so we would like the performance to indicate what this percentage should be in their proposal. In phase 1, with reject option classification, we would like an improvement in this classification by 15%. If your problem is different from a classification problem, you can adjust what is meant by misclassification accordingly. We would like this to improve to 30% and 45% in phases 2 and 3 respectively. The second metric that I'd love to talk about is when clinicians are aided by the uncertainty estimation tool. So the first one was just the uncertainty estimation tool itself, but this is clinicians aided by it and other communication tools developed in TA3, in addition to the TA2 tools. We would like, for example, a reduction of false negatives at a given specificity while using the AI DSD, comparing without versus with the use of precise AI tools. We would like this reduction to be 20% with the tools listed on that line in 50% of use cases or more in phase 1, increasing to a 40% reduction with all the tools in 100% of use cases in phase 3. Finally, the last metric that I would like to talk about at the very bottom is time for case interpretation with TA3 tools relative to no tools. As described in the previous slide, we expect bidirectional communication between the AI model and the clinician. This may initially make the case interpretation slower, which is not what we want for the final tools in the program. We believe that with properly designed tools and a clinical flow, the case interpretation time should remain unaffected by the end of phase 2 and should actually be faster with the TA3 tools at the end of the program. as shown in the phase 3 box at the bottom right. Okay, this takes us to TA4, the core data infrastructure, which is aimed at enabling autocorrection of AI DSTs in real-world clinical settings at each level. The core data infrastructure will aggregate analysis and results across performers, clinical sites, and use cases to create a consolidated data sharing infrastructure to advance TA1, TA2, and TA3 technology development, including ground truth sharing among performers and reporting mechanisms. TA4 will also provide common data infrastructure capabilities using existing data repositories and cloud services to facilitate data sharing and minimize costs. It will leverage and extend standardized models for AI DST input, metadata, output, ground truth, and other relevant elements. TA4 will also provide APIs for data and model sharing. In addition, TA4 performance will maintain privacy and security standards for the entire program. Here are the metrics for TA4. We expect TA4 performance to support almost all data types requested by TAs 1 to 3 and support all clinical sites in the program. Finally, TA5, which will perform the independent verification and validation of other performance. The IVNV team will quantify overall program success by using evaluation metrics aligned with program objectives. They will do this by, first of all, working with clinical sites and all performers to appropriately collect and integrate needed performance data. Although clinical sites may include the sites that TA1 performers are already working with, strong TA5 performers will use additional data collected at additional independent clinical sites to ensure generalization. TA5 performance will analyze performance data using appropriate metrics to drive an outcome-targeted set of evaluation results, provide feedback for performers and ARPA-H on program metrics and evaluations at appropriate intervals, provide clear communications on the entire metric evaluation pipeline, and oversee adherence to data engineering and interoperability standards. This slide shows our collaboration expectations. We envision a program where the performers really work very closely together to achieve program goals. There is a more comprehensive table in the solicitation, but I want to highlight some of the most important aspects. Starting with TA2 performance, the use cases will be brought to the program by TA2 performance, as I described earlier. We would like TA2 performance to provide access to the executable code for these AI DSTs to TA1 and TA3 performers so that these performers can at least run these models on their own. If TA2 performers can provide access to their source code to other performers, it's of course much better. For example, for certain methods for uncertainty estimation for TA3, it may be advantageous to access the source code. Of course, a TA2 performer or proposer can submit a combined proposal to TA1, TA2, or TA2, TA3, or TA1, 2, and 3, so that their proposal is vertically integrated. This is true for all proposers, not just TA2 proposers. TA1 performers are expected to provide clinical AI model input data and surrogate ground truth and clinical subject matter expertise to both TA1 and TA3 performers. TA3 performers are expected to collaborate with TA1 performers on the design and test of AI clinician communication tools and multi-reader, multi-case, and field studies to investigate the effectiveness of the developed tools, and with TA2 performers on the communication tools. Finally, all performers are expected to work with the TA4 performers for seamless data and code exchange, and with TA5 performance on data and code availability for IVN. To facilitate the open exchange of information described above, performers will have associate contract agreement language included in their role. Each performer will work with other precise AI performers to develop an ACA that specifies the types of information that will be freely shared across performer teams. This open exchange of scientific information will be critical in advancing the software research required to achieve precise AI objectives. This slide shows the milestones and the timeline for the program. I will not belabor it, and a copy is in the solicitation. I will just mention that this is a 4-year program with phase 1 involving prototyping and initial tool development, phase 2 involving testing, improvement and expansion, and phase 3 involving integration. At the end of phase 2, the performers will regroup into integrated teams that will design products that are ready for market transition. For the solution summaries, we would like you to include a basis of estimate for your costs for the entire duration of 4 years. For those who are encouraged to submit a full proposal, we would like you to submit a detailed budget for phases 1 and 2 and a rough order of magnitude budget for phase 3. Please note that most of the key deliverables shown at the bottom are open source software. We expect that all the software developed through the program will be made available to the community as open source. This expectation, of course, does not include any software that the performers bring to the program that were designed before the program. For example, when a TA2 performer brings their already developed AI DSD into the program, we of course do not expect that that AI DSD will be made publicly available at any portion during or after the program. Affordability and accessibility is very important. This paper, published in 2020, shows that patient data for training clinical machine learning algorithms typically come from only a few states in the US. Most states contribute no data, which is not what we would like to be repeated in Precise AI. The performers in the Precise AI program will be expected to ensure that the data collection is inclusive both geographically and demographically, and the program requirements include equitable AI performance based on appropriate subgroups. While discussing the metrics for different TAs, I discussed several considerations for equity for data collection, performance monitoring, and correction tools and analysis methods. These are required so that Precise AI results in tools that enable clinical AI models to self-update and perform well for all subgroups. Finally, I would like to emphasize that the goal of Precise AI is to impact all stakeholders, including patients, hospitals, clinicians, developers, and regulators, as summarized in this slide. For patients, the goal is to reduce the likelihood of harm caused by incorrect medical decisions due to degraded AI model output. For clinics and hospitals, the goal is to enable them to monitor and fix AI tools that demonstrate performance degradation. It will also let them know how the model is performing in their clinic compared to others, letting them better understand the value that they are gaining from the model. For clinicians, the goal is to provide both better performance and improved communications tools, enabling them to interact with AI tools in a new and time-efficient manner. For developers, it will provide access to open source software and toolkits for continued innovation on AI model performance. For regulators, the benefit of the program is that it can add to the total lifecycle evaluation by providing tools that enable continuous monitoring of performance of cleared AI-enabled decision support tools. As I mentioned a couple of slides back, we would like the tools developed in this program to reach real-world applications that are actually used in the clinic. And whether you, as a performer, are a developer, part of an academic institution, or part of a clinical team, I'm sure that this additional motivation will allow you or will motivate you to take part in this bold and innovative program. This is my last slide. Here are the anticipated due dates for our program. As our agreements officer, Adria Robinson, will also explain later this morning, you need to submit a solution summary first by the anticipated deadline shown here, November 7th for the solution summaries. We will then issue discourage letters for full proposal submission, and the anticipated full proposal due date will be early January 2025. Please monitor our program website and SAM.gov for any changes. We currently have a draft solicitation on the SAM.gov page, and it will be very soon replaced by an amended draft solicitation, and then a final solicitation, which may also be amended in time. Please thoroughly read the program solicitation and conform to all the requirements therein. Non-conforming proposals will not be evaluated or considered for award. So this completes my presentation and my program overview. Next, we have a presentation by Dr. Ron Summers on recent advances in radiology AI. Next slide, please. And let me briefly introduce Dr. Summers before I leave the podium and turn the microphone over to him. Dr. Summers, Ron Summers, MD, Ph.D., is a tenured senior investigator and staff radiologist in the Radiology and Imaging Sciences Department at the NIH Clinical Center in Bethesda, Maryland. He is a fellow of the Society of Abdominal Radiologists, the American Institute for Medical and Biological Engineering, and SPIE. His awards include the Presidential Early Career Award for Sciences and Engineers, the NIH Directors Award, and the NIH Ruth L. Kirstein Mentoring Award. He's a member of the editorial boards of Radiology, Artificial Intelligence, Academic Radiology, and the Journal of Medical Imaging, and a past member of the editorial board of Radiology. He has co-authored over 650 journal, review, and conference proceeding articles, and is a co-inventor on 17 patents. His research interests include thoracic and abdominal imaging, large radiology image databases, and artificial intelligence. So Ron, I believe you're online and ready to take over.
Okay, these are my disclosures. Next slide, please. So it's a great pleasure to be here today, and I'd like to thank Berkman and his colleagues for inviting me to speak. The research that I'm going to present to you today was done at the NIH Clinical Center, shown here, located just outside of Washington, D.C. in Bethesda, Maryland. And this is the world's largest hospital devoted entirely to clinical research. The themes that I'll cover in this presentation include new radiology AI applications and new methods of annotating training data. And I'll try to relate these to the various goals of the program that you just heard about. So one of the large projects that I've been involved with in a collaboration, which I'll tell you a little bit more about in a minute, is on body composition. And probably most of you are aware of some of the traditional body composition metrics, like the measurement of body weight, waist circumference, body mass index, and lean muscle mass. These are inexpensive or free to measure and are excellent surrogate biomarkers for a patient's health and risk of disease. And you may or may not be aware that these body composition markers are playing an expanding role in clinical research and practice. And as AI systems can provide more comprehensive body composition assessments, we're likely to see this area expand even more. Next slide, please. So the projects that I've been working on have been in collaboration with Dr. Perry Pickard at University of Wisconsin-Madison, shown here. This project is over a decade in age and has led to dozens of clinical papers. We've developed 5 AI tools, and the number are increasing as we continue our collaboration, and the AI tools are continuously improving. In addition, we've been able to assess such issues as domain shift in this work because of the large number of cases that we're able to analyze as part of this study. Next slide, please. So the 5 AI tools are shown here. In the upper left is one that assesses hard plaque in the abdominal aorta on CT. In the upper right, an AI tool that assesses fatty infiltration of the liver, also known as liver steatosis. In the lower left, shown on the axial CT slice with the red coloring, is the assessment of muscle quality and quantity which are both important factors in assessing patient frailty. And this has implications for adverse outcomes following such interventions as chemotherapy and surgery. The image in the middle on the bottom row shows an oval yellow region of interest over the bone marrow in the upper lumbar spine, and there's a measurement of Hounsfield unit CT attenuation there. This is an automated tool, AI tool that assesses bone mineral density, and that's important in assessing for osteopenia and osteoporosis. And we've done some studies showing how this and the other metrics can be helpful in predicting fractures in the spine and in the hips. And in the lower right is the fifth AI tool. It assesses visceral and subcutaneous fat. The visceral fat is shown in blue and the subcutaneous fat in red. And each of these have been implicated in such disorders as metabolic syndrome and diabetes. And I'll tell you a little bit more about that in a bit. So next slide, please. So what we've been doing is using these 5 AI tools to assess a variety of risk factors and overall survival. And in this first project, we assessed cardiovascular risk and mortality in a paper published in Lancet Digital Health back in 2020. We applied these AI tools to abdominal CT scans of about 9,000 patients. And in the next slide, you'll see these ROC curves that show that the AI developed surrogate biomarkers such as aortic calcification and muscle density shown on the left-hand ROC curves on the bottom row have higher AUCs than the traditional easy body composition metrics such as body mass index and Framingham risk score, a cardiovascular risk metric shown on the top row. And on the right, the ROC curve shows an area under the curve of 0.81, which exceeds that of the individual biomarkers. And this was from a combination of the aortic calcium tool, the muscle density tool, and the liver density tool. Next slide, please. So this is an example of a 57-year-old man who is undergoing colorectal cancer screening with virtual colonoscopy. He had a very high visceral to subcutaneous fat ratio, indicating a large amount of visceral fat. He had a very low liver density, indicating a high amount of fatty infiltration of the liver. And he had a very high abdominal aortic plaque score in the 97th percentile, indicating a very high amount of plaque. And 12 years after this original CT scan, he had a repeat CT shown on the far right, in which the liver fat increased, the abdominal aortic plaque increased, the visceral fat increased, and the muscle quality became poorer. And each of these factors indicated a lower risk, a lower probability of overall survival. And in fact, this patient expired shortly after that scan on the right. Next slide, please. In another patient, this in a woman, she had a bone mineral densitometry measurement of only 63 Hounsfield units, which is very low in the osteoporotic range. She had low quality paraspinous muscles shown in the middle image on the top row of only negative 1.7 Hounsfield units. That should have been in roughly the 30 to 40 Hounsfield unit range. And 3 months after that scan, she developed a fracture of her left hip. And I think the key thing to recognize here is that if this sort of AI-based opportunistic screening had been used as part of her clinical care, the physicians would have noticed that her bone mineral density was successively decreasing over the time of multiple CT scans that she underwent, as shown on the bottom row of images, and could have led to earlier intervention. Next slide, please. So one of the things that we found when looking at these AI developed biomarkers was that muscle fatty infiltration was an underappreciated risk factor for lots of different adverse outcomes, including overall survival reduction and cardiovascular risk. And in this example shown on the left, you can see CT scans from two different patients. One, a man, a 51-year-old man on the left, and the image on the right of a 53-year-old man. And the man on the right has a lot of fat infiltrating his musculature, shown in yellow. And this man died about 9 years after this CT scan, whereas the man on the left was still alive at 13 years after follow-up. And what we have found in a series of studies published in different journal publications is that the hazard ratio for myosteatosis, or muscle fat, exceeded that from obesity, liver steatosis, and decreased muscle quantity alone, indicating that this under-recognized factor could be a very important area for intervention in clinical care, particularly of the elderly. Next slide, please. Before I talk about this slide, I'll just mention that in the series of studies that we did that I've just shown, we also looked at the effect of domain shift. And it was mentioned in the previous presentation that there's a need to evaluate patients from all over the country, not just from specific states. And one of the projects that we did was to look at outside CT scans. We had outside CT scans from 700 different hospitals, and we found that these AI tools were robust across the breadth of this large number of different acquisition protocols and patient populations. So that's the kind of thing that you can do with these AI systems that are fully automated. I've mentioned 5 AI tools, so now I'll just briefly talk about some new ones that we're working on. This one looks at the pancreas on abdominal CT, and we were able to show in a study led by Hema Talam and published in Radiology in 2022 that patients with pancreases that have fatty infiltration or lobulated contours are more likely to have diabetes. Next slide. And Hema, who's now an MD PhD student, showed in the study that in patients who've had diabetes diagnoses for the longest periods of time, the CT attenuation of their pancreas was very low, on an average about 10 Hounsfield units compared to the normal value of about 30 Hounsfield units. So what we found here is that one could opportunistically screen for diabetes, and it's known that a substantial fraction of Americans who have diabetes it's under-recognized that they have diabetes, and opportunistic methods like this one using AI systems might play a role in reducing the incidence of under-recognized diabetes. Next slide, please. I mentioned that we've tried to develop new AI applications for radiology. This is a new one that we just reported several months ago, and is on assessing third spacing or edema in patients who have organ failure like liver, kidney, or heart failure. And this particular patient had a large amount of subcutaneous edema, which was detected by this AI system shown in green on the right. Next slide, please. Lymphadenopathy is an area that we've been very interested in. It's particularly important for oncology patients. We've done most of our work on CT scans of oncology patients with lymphadenopathy, but more recently we've extended this to MRI scans. And I'll just give a shout out to a publicly available data set of over 150 CT scans that we put on TCIA of patients with abnormal lymph nodes that you can use for your research. Next slide, please. There are many excellent segmentation tools for CT scans, but fewer for MRI scanning. This is an example of work just reported by Yan Zhuang, a former postdoc in my group, and you can take a look at his archive paper. As you can see, his system is able to automatically segment over 60 different structures on abdominal MRI scans, and the AI model and software are available with a link in that archive paper. I encourage you to take a look at it and check it out. Next slide, please. This is an example of the ability of this MRI organ segmenter to identify organs even if they have lesions in them. In the middle column, you can see a kidney with a large cyst. That's the green segmented structure. And on the far right, you can see a liver with many metastases from metastatic cancer. That's the cyan organ on the left side of the images in the rightmost column. Next slide, please. In the remaining minute or two, I'll just mention that this MRI segmenter has excellent performance with dice coefficients over 90% on many different structures. Next slide, please. We've created a similar AI tool for liver assessment in patients with cirrhosis. And these images show 4 different patients with different degrees of hepatic fibrosis with Quino segmentation. And this has proven helpful in assessing patients for advanced cirrhosis, even in patients with ascites. The bowel is a frequent source of abnormalities, and there's a paucity of AI tools for evaluating bowel. There's been some work on looking at inflammatory bowel disease like Crohn's and ulcerative colitis. This is an example for a carcinoid tumor, a type of neuroendocrine tumor. These are sub-centimeter lesions in some cases and very difficult to detect. Next slide, please. In the last few seconds, I'll just mention that we've started looking at large language models for annotating images without large amounts of manual annotation. This is an example of work from Pritam Mukherjee in my group using a publicly available privacy-preserving AI system, large language model system that can be run locally so that you don't have to upload any data to the cloud. And it can extract labels for chest radiographs. Next slide, please. And finally, this work that just came out a couple of weeks ago showed how to use multimodal large language and vision models to assess a combination of radiology images and text in RSNA case of the day examination, showing that a commercial large language model and vision multimodal system performed as well as radiologists and radiology residents, although it did not help either of those two groups improve their performance. So I'd like to thank you for your attention. The work that I showed was done by the people shown in this slide, all members of my group. And I'd like to thank my various sources of funding and collaboration. Next slide, please. And if you'd like to learn more, please check out my lab's GitHub site and our website. And please don't hesitate to contact me if you have any questions. Thanks so much.
Thank you very much, Ron, for that wide-ranging presentation that showed the gamut of applications of AI and abdominal radiology and what it is really capable of. So next in our agenda, we have Dr. Gada Zamzmi from the FDA. Let me introduce Dr. Zamzmi before I again cede the microphone to her. Dr. Gada Zamzmi is a staff fellow at the Center for Devices and Radiological Health, where she leverages her expertise in machine learning and medical imaging to develop methods and build tools for evaluating and monitoring AI-enabled medical devices. She currently leads the AI monitoring efforts within the Division of Imaging, Diagnostics, and Software Reliability. Prior to joining the FDA, Gada worked as a research scientist at the NIH, where she applied her machine learning expertise to develop computational health models. GADA holds 5 patents related to AI-based technologies for healthcare and has authored over 40 papers in conferences such as MICAI and NeurIPS, as well as prestigious journals such as Medical Image Analysis and the Journal of Machine Learning Research. She has been recognized with several awards, including the MIT Innovators Under 35 Award. So Gada, I hope you can hear me, and the microphone is yours.
Thank you, Berkman, for the introduction. And I'm happy to be here today talking about our perspective on monitoring AI-enabled medical devices. Before we start, these are some disclaimers, and I want to emphasize that today I'm not speaking on FDA policy. Some of you might wonder why FDA, which is usually known for Food and Drug Regulation, is talking about monitoring AI devices. So let me just give you a very brief summary of us. FDA has many centers. One of them is CDRH, the Center for Devices and Radiological Health. Within CDRH, we have several offices. One of them is the Office of Science and Engineering Lab. OSIL is the research arm of CDRH. It has several research programs. One of the biggest research programs we have is the AI machine learning program. This AI research program has many scientists who conduct AI research and provides AI consultation. So the scientists in this program, they wear the researcher and regulator's hat. So this slide explains why we have an AI research program. As shown in the plot, the number of AI-enabled medical devices has been increasing over the years. We can see a big jump around 2015, and the majority of these devices are coming from radiology. Because of this, we need to conduct research that focuses on creating tools for evaluating, regulating, assessing, and monitoring these AI devices. Our AI research program focuses on user needs. Our AI research is driven by stakeholder needs. We engage with stakeholders to identify gaps and then build projects to address these gaps. So our dialogue with the stakeholders lead us to identify 6 major gaps within the AI research program. Today, I'm going to cover the last one, which is gap 6, that focuses on post-market AI device monitoring. So as Berkman stated earlier, that there are many causes of performance drift, like the locked AI models that are usually developed in controlled and static environment tend to drift when they are deployed in the real-world clinical environment. These drift can happen due to many reasons, including change in the population demographic, change in the imaging devices or scanners, even sometimes change in the clinical guidelines or the clinical behaviors of the clinician or the patients. And sometimes the change can happen over time. This is also known, the change over time, also known as AI aging. This study explored the concept of AI aging by exploring the change in the model sensitivity in the absence of major data drifts. The study explored 4 machine learning models, linear regression, random forest, gradient boosting, and neural network. And they explored 32 data sets from 4 industries, from like weather industry, hospitals or healthcare, airlines, and financial industries. Next slide, please. To simulate the issue of AI aging or how the model performance change over time, they generated 20,000 simulated experiments by randomly selecting training times before T0 and then testing the model on future data after T1. So in that plot here, you can see like the yellow box that says it's history and then time T0. So what they did is that they trained the models on data points before T0, and then they tested the model in the future data points. Then they reported the testing error in the plots here. Each point in this plot represents the error for one experiment, and the x-axis represents the time, the days after the training, and the y-axis represents the error. And as we can see, the model error increases as the numbers of days increases. So as the number of days after the training increase goes up, the model performance also, the model error also goes up. This study concluded that 91% of the machine learning models degrade in time. So this is a major problem. Performance drift is a major problem. Next slide, please. So in order to have some tools for monitoring performance drift, we need first to define what is AI monitoring. We define AI monitoring as the proactive assessment of device performance, not only collecting device problem. This AI monitoring should include tools for proactively checking incoming data and actively collecting device performance. This monitoring is different than it's different than adverse event reporting, compliant handling, and MDR reporting. Next slide, please. By building monitoring tools, we're hoping to move from the state above where we don't have an approach or method for understanding the data quality and AI performance over time to the state in the bottom where we have methods that help us detect change in data characteristics over time, as well as change in the performance and potential causes of these change. Next slide, please. No matter if the model is static or locked or adaptive, we always need tools to monitor how these models perform during deployment. And actually, the importance for monitoring these AI model increases as we move from static to adaptive models. Next slide, please. Building monitoring tools can be helpful not just for the regulators, but for end users, as it enables them to monitor and fix AI tools that shows performance degradation. This can ensure patient safety by reducing risk to patients, clinicians, and overall hospital operations. So to enhance safety and prediction accuracy, the AI model life cycle can iterate with development, deployment, maintenance, and monitoring. Next slide, please. I want to spend a few minutes talking about some of our current efforts here in building tools for monitoring data and performance drift of AI model. Several considerations need to be taken into account when developing monitoring tools. The first one is what we want to monitor. If we want to monitor change in the data, we need to first think about the features in the input that we want to monitor and how we can convert these images. Like, for example, if I want to monitor change in image characteristics, how can I convert the image from the high dimensional space into a signal that I can monitor over time? If I want to monitor the model performance, I need to think about what are the performance metrics that I want to monitor. Like, do I want to monitor the sensitivity, the specificity of the model? And also, we need to think if there is any potential relationship between changing the input and changing the model performance. Does changing the input always impact the model performance? Next slide, please. After deciding what we want to monitor, we need to also think about how to monitor. What is the method that I want to use to monitor change in the signal? One approach is the statistical processing control, which is a well-known method that has been used in industry to monitor the quality of the process. This is one way that we can use to monitor change in the signal. Another consideration that we need to think about is when to raise a flag, like what is my threshold? We also need to decide the frequency of monitoring. Do I want to monitor the performance drift weekly, hourly, monthly? and when should a flag be raised. So all these things we need to think about when developing a monitoring tools. Next slide, please. So in our AI monitoring program, we design a method to monitor shift in data. So we convert the imaging data into a similarity matrix and then log these similarity metrics into an SPC chart to be able to flag any deviation in the data characteristics. I'm not going to go over the details of this method. If you are interested in knowing the details, you can check our paper. I have the citation here. With this paper, we published a tool that is publicly available. It's open source. These tools will receive incoming data as input and flag change in the data characteristics. If you're interested in knowing more about our tool for monitoring data shift, you can scan this QR code and you will have access to the paper and the code. We also developed a tool to monitor drift in the performance of an AI model designed for a mammography task. Specifically, we use a cumulative sum, which is one type of SBC method, to monitor drift in the model specificity due to change in the data. And we simulated a change in the data by adding a median filter. This change, which is caused by adding the filter, lead to a change in the specificity, and we were able to track this over time. Again, the paper is here, you can read the details of our method and our simulation there. This paper also has a code or tool for monitoring a change in the model performance. The tool would receive incoming data. The tool will receive the prediction or performance of the model, and it will tell you it will send an alert for deviation or drifts in the model performance based on some predefined thresholds. So the code include different ways for changing the hyperparameters and the threshold, and you can explore this if you want. To conclude, we want to emphasize that whether the model is static or adaptive, predictive, analytical, or generative, AI models face the challenge of performance degradation during deployment. This is a reality. Current approach for monitoring are manual, they're not scalable. Therefore, we need to develop tools for monitoring change in data characteristics. We need tools for tracking the performance of AI models over time, as well as identifying the causes of performance drift. Thank you. And if you're interested more in knowing about our AI monitoring program, please feel free to scan the QR code, and here's the email. You can always email me. Thank you.
Thank you very much, Gada, for that talk that really explained the importance of AI performance monitoring from an FDA perspective.
Hi, good morning, everyone. My name is Adria Robinson. I am the Agreements Officer at ARPA-H, supporting Berkman and the Precise AI program. And I'm going to chat for a few minutes with you about all of the contractual requirements surrounding their submissions and how we're going to handle the awards under this program. All right, I cannot emphasize that first bullet on the screen enough. Please follow the instructions. You all are going to spend a lot of time and money putting together your submissions. You don't want it to be determined to be non-conforming. So please follow the instructions in the solicitation. Please use the forms and the templates that we provided. Do not create your own. Particularly the pricing template and the admin and national security forms. Please make sure you fill everything out in the format that we provide. If you have questions on those attachments, if you have concerns, you can submit those as part of the question and answer submissions, and we can make changes to those as necessary, but we do ask that you don't use your own templates. All communications need to be via the Precise AI email. Please do not reach out to Berkman or any of his CETA team directly. Please do not reach out to others at ARPA-H directly if you have questions that are specific to this program. We need to be able to keep everything in one place and make sure that all of you are receiving accurate information. Your IP assertions, so if you have any intellectual property assertions, they must be included in your proposal. You cannot say none and then come back later during award negotiations and say, just kidding, I want to restrict all of this intellectual property. You must include it upfront in your proposal. The research security disclosure, so that's part of that admin and national security form I mentioned. At the beginning of that, we do ask for a list of everybody, but then we go into some more specific questions about current and pending other support and so forth. Those questions you only need to answer for the senior and key personnel, not for everybody performing. We're not going to dig in to those individuals that are not listed as senior and key personnel. Federally funded research and development centers and other United States government agencies are not eligible to propose as either prime performers or as sub-performers on a team. So as you're putting together your teams, just be careful. You also cannot propose personnel on your team who are current US government employees. As Berkman mentioned earlier, when you submit your full proposals, we are only requesting the detailed budget for phases 1 and 2. For phase 3, we're just asking for a rough order of magnitude. And so you'll see in the spreadsheet that we provided up front, there is a table where you can enter your phase 3 information, but we don't ask for that on the subsequent tabs in that spreadsheet. Next slide, please. Right, solution summaries are required for this program. This is not the case for all ARPA-H programs. So understand that in order to be able to submit a full proposal and have that proposal reviewed, you must submit a solution summary. You can submit a full proposal regardless of whether your solution summary is encouraged or discouraged, right? So when you submit those solution summaries, you will get feedback on them. And regardless of that feedback, you can submit a proposal. However, we do ask that you take our feedback into account. If we discourage you from submitting a full proposal, please consider whether or not it is worth the resources to actually move forward with submitting a full proposal. Another thing I'd like to add about the solution summaries is this is your opportunity to get feedback. We can't provide, outside of the sidebar sessions we're doing this afternoon, we cannot provide individual feedback via email or phone call or anything like that. So please make sure that you utilize the feedback we give you on your solution summaries because that's that opportunity. All submissions, whether solution summaries or proposals, must be submitted using the method that we outline in the solicitation, and they must be on time. So, life hack, do not try to submit 10 minutes before the deadline. Because what happens is it will break, right? Murphy's Law is going to hit everyone and it will break. And I cannot accept late proposals, right? We're going to run this as a very fair competition. So please make sure that you do the things that you need to do to be able to submit on time. And your SAM registration must be active at the time you submit. I'm emphasizing this because SAM registration can take a while, depending on the specifics of how your organization is set up. So if you are interested in submitting, I would make sure that you are, number one, if you're already in SAM, checking to make sure you're active. But also, if you're not in SAM and need to set up a new registration, make sure you start that process a couple of weeks ahead of time. And this is for your proposals. It does not have to be active at the time of your solution summary submissions, but at the time of your proposal submission. Right, your proposal, when you submit, there are 5 TAs, as Berkman outlined. You can submit to any combination of TAs 1 through 3, or TA 4, or TA 5. If you submit to TA 4, you cannot submit to any other TA. If you submit to TA 5, you cannot submit to any other TA. Right, your phase 3 proposals, and I apologize, that is so small. The plan for phase 3 is at the end of phase 2, there will be a down selection of the existing performers moving into phase 3. So the existing performers will have to repropose. At that time, you can restructure your teams, right? You might decide to combine with some other performers. You might decide to do an independent restructure of your team. That will be up to you. But you will be expected to repropose. That phase 3 proposal must address all 3 of TAs 1, 2, and 3. Regardless of how you performed, which TAs you performed on in the first 2 phases. So as you're thinking about that team restructuring, make sure that you're considering the fact that you need to have a team that can address all 3 of those TAs going into phase 3. All right, an overview of the process. So the solution summary submission, again, it is required. The length of the solution summary should be 3 pages if you're addressing 1 TA. Or 6 pages if you're addressing multiple TAs. This doesn't include your cover letter, your rough order of magnitude, the basis of estimate for your pricing. Make sure that you use the template that's provided. You need to address all of the sections in that template. We are reviewing solution summaries, not evaluating them. So what's the difference? In the solicitation, we provide you with the evaluation criteria. That criteria will be used for the evaluation of your proposals and the ultimate selections for award. The solution summaries are not being reviewed against those criteria. It's more so an opportunity to, again, provide you feedback on, your proposed solution for this program. And I've just provided our submission website there at the bottom. Your full proposal, so we will encourage, as I said, or discourage submission of a full proposal based on your solution summary submission, and then you can choose to submit or not submit. We will use, and I do have a slide that will go through the evaluation criteria in just a moment. So one thing, that last bullet on the right, I talk about an innovative solution opening. So if you look at the draft solicitation that we posted, we refer to it as a program solicitation. ARPA-H is now going to refer to all of our solicitations as ISOs, innovative solutions opening. So when you see the final solicitation, you will see that language instead, but we're talking about essentially the same document. All right, these are the evaluation criteria that I mentioned. They are in descending order of importance. So they will all be utilized in the evaluation of the proposals and the selection recommendations and decisions, but you can see how we prioritize them. You're going to your cost and price proposal. So there are 2 pieces to this. There is your spreadsheet, and then there is the narrative or justification. Please do not repeat what's in your spreadsheet in your narrative and justification. The purpose of that document is to provide us with additional information to support the numbers in your spreadsheet, right? So this program is going to be funded with taxpayer dollars. So we have to justify everything that we are going to agree to pay you as you execute this program. So use that narrative and justification to provide things like quotes or explanations. If you have rate agreements with the government, provide us copies of those. Those are the things that we are looking for in that narrative and justification. And make sure that you provide, if you're proposing materials, equipment, anything like that, that you actually provide us with a list of what you're going to be purchasing and not, miscellaneous or contingency, right? We need to know what we are actually going to be approving and paying for. Under this program, we are going to be awarding other transaction agreements. So these are different from the standard FAR-based procurement contracts. They are different from grants. They are different from cooperative agreements. Other transactions allow us to be able to negotiate with you all and work with you all in a more commercial type environment. So the beauty of the other transactions is because they don't fall under the FAR, the Federal Acquisition Regulation, they don't fall under the grants and cooperative agreement regulations. we have a lot of flexibility to negotiate things. And so what you'll see is across the program, no two agreements are going to look the same. I talked about intellectual property. You know, that's an area where using other transactions allows us to work with you on the specifics of what you all need to be protected and how we're going to do that. But in the general sense, we could with some of the other contractual options. All right, so just to hit on some points, monitorsam.gov, as Berkman mentioned earlier, that is where everything is officially posted. If you are having trouble navigating SAM or finding stuff out there, go to the Precise AI program page because we link you to where our stuff is posted on SAM. Nothing that we talk about here, it takes precedence over the solicitation that's posted. So what we do intend to do is if we give you conflicting guidance today is to amend what's posted online so that it matches. But if you do find a discrepancy, then the posted solicitation is what governs. Make sure that you pay attention to the eligibility requirements in the ISO. One thing I do want to mention is that comes up a lot is about foreign, non-US entities, and non-US entities are allowed to participate as performers under ARPA-H programs. So that should not be a barrier if any of you want to team with entities outside the United States. We do have to, per our statute, prioritize research that is being performed on US soil, but that does not preclude you all from venturing outside of our borders. As Berkman stated, non-conforming proposals will not be evaluated or considered for award. We'll provide you, with a notice that your proposal was non-conforming. And the due dates that Berkman mentioned are on the right-hand side. And again, please use the Precise AI email box for any questions. I will take couple minutes if anyone has any questions. If you have questions, please use the microphones so our friends online are able to hear.
So you mentioned very strongly that if you do a proposal based for TA4, you can't propose to any of the others. Can you submit along with others for the feedback phase again, the solution?
The solution summary? Yes.
Okay.
Yes, you can. And then you'd have to choose from there, right, which to move forward with. Perfect. Any other? Oh, yes.
Hi, thanks. College of AI. So I have a question about the IP. So in bits today, there's sort of strong declarations about IP is going to be where products are developed over the course of, for example, dashboards that are communicating uncertainty as part of TA. Is the intention that has to be open source, or is it the kind of principles that underpin what's being presented?
Yes, the intention is that if it is developed with the ARPA-H funding, then it is open source. But again, then there might be situations where that may not apply, but that's our intention. Our intention is
Right. Hello, John Callow, right? Question on the mini proposal, in terms of expectations on the basis of expense. Or can you give any guidance in terms of the formality, the length, or what you're looking for in that?
Yeah, we're definitely at that stage. We're not looking for you to provide a bunch of detailed backup information. We recognize that those basis of estimates can and likely will change between your solution summary and your proposal, and that's okay. What we're trying to do is get an idea of kind of the range of prices early on for budgeting purposes.
And to include narrative in that.
You don't need to include narrative unless there are things you feel you need to explain.
Okay, Marcy from Stanford. Question: if you're considering submitting for multiple TAs, do you need to fully address all these TAs you submit for entirely, or could it be you have one focus on the TA3 that you a little wider focus on TA4?
So if you are submitting and you are requesting an award for multiple TAs, you need to provide us with enough information so that we can feel confident in your ability to perform under all of the TAs that you're submitting under.
Fulfill all of it.
Correct. Yes.
Stephen Martin. So with the solution summary submission, or is it a full submission that you need to have the cooperative?
So we will negotiate the awards you're asking about?
Yeah, I'm just making sure that we don't have just a couple of days to get cooperative.
So the award from ARPA-H is going to come later, right? Or you're talking about for your teaming?
For the team.
For the teaming, yeah, so we don't dictate how you handle your teaming. We have a lot of entities across the federal government who will put teaming agreements in place, but they won't actually negotiate the details of those awards until actually after they get their prime award from the government. So we are not expecting you to have all those details hashed out when you submit anything.
Andrew Burnham, Teledyne Scientific. So if you were looking to run one of the clinical tracks other than X-ray, CT, or health records, is it necessary to apply with TA 1 through 3, or is it a combination of TA 1 or 2 or 3, a combination of those 30 examples?
I can answer that. It has to at least cover TA1 and TA2. And then it might also cover TA3, but that's not required.
Okay, thank you very much.
We will take this as our last question.
So I think there's a lot of emphasis on teaming between the TAs. Do you prioritize teams that come with additional teams, cooperative teams? I know there's team profiles, et cetera. Or if we already have a pretty staffed team, is that okay?
Yeah, so what we look at in terms of your team is, are you presenting us with the capabilities across your team to do the things that you're proposing to do? There will be collaboration across the TAs in performance, and that's sort of a separate, you'll have your separate awards, but you'll have, as Berkman mentioned, those associate performer agreements that will outline how you'll share information. But you don't have to come to the table with a, for example, TA 1 through 3 team already formed.
So there isn't really a preference one or the other, as long as you show the capability.
Correct. We are only evaluating against the evaluation criteria we've stated in the solicitation. We cannot and will not venture outside of those four walls.
Thank you.
Welcome. All right, I'm going to introduce our next presenter. All right, so I'm going to introduce to you Dr. Miriam Ziai. Miriam is a technology innovator and business leader with over 15 years of experience in healthcare and advanced technology. As a startup founder and CEO, she developed the world's first FDA-cleared AI-driven breast health monitoring platform. Currently, she leads the technology transition and transfer division at ARPA-H, partnering with ARPA-H programs and leadership to ensure high-impact technologies translate to real-world solutions. Miriam holds a Ph.D. in electrical engineering from Stanford University and is an alumna of Y Combinator. Her work is dedicated to enhancing healthcare access and equity through innovation.
Thank you so much, everyone, for having me. I'm excited to be here today and speaking to you on behalf of PATIO, Project Accelerator Transition Innovation Office, which is ARPA-H's Technology Transition Office. My role specifically, I'm a Director of Technology Transfer and Transition. What is PATIO and how do we work? We are one of the 5 mission offices at ARPA-H, and we work with the program managers and performers across the entire ARPA-H to help them to make sure that the technologies that are developed in these programs translate to become impactful solutions and reach everyone and accelerate better health outcomes. Next. because ARPA-H will not obviously fund performers in perpetuity, Patio's goal is to increase the odds that these technologies transition and become successful and translate into impactful solutions. And how we do that is that we partner with program managers and performers. We provide a range of capabilities towards commercialization and transition that can help improve their success rates. Next, taking a step back, how do we think about a successful innovation? And this framework was originally developed by IDEO. But when you think about a successful innovation, of course, the technology is super critical. It has to be feasible. But there are other aspects that are key to its long-term success, and that's desirability. Do people want to use and adopt this technology? And is there a viable business plan? Is this innovation sustainable over time? These two, at the intersection of these three, lies true innovation that can have long-lasting impact. So taking a step back, we think about and design with the end in mind. Where might a solution from ARPA-H go afterwards? These are some of the categories that we think about actively. It can be a de novo startup, emerging company, VC-backed or backed by capital, and then it can be a large established strategic company. There are other transition ways beyond just commercialization that we think about. These pathways can be a healthcare system, another government agency, or an NGO, whether it's small or large, nonprofit organization. So these are some of the places that might go. And as we start thinking about transition and building metrics and goals towards transition, it's important to have that end goal in mind so that we can put the right strategy in place. When you think about technologies that don't become actual product and then don't get to patients, actually most of the time is not the technology that failed. What fails is some other factors, and we typically categorize this into these 6 buckets and in a general sense. It can be product development, and there's a distinction between a technology or science and whether it is actually can become a full-scale product that can be deployed, it can be manufactured at scale. There's do people want to use and adopt this solution? And one thing that ARPA-H we specifically really care about is this accessible? Can this reach everyone? And then finally, there's of course stage gates such as regulatory or IP. And the business model is also really important. Can this financially survive and compete? Is there reimbursement for it? Is it affordable? What's pricing strategy? And then finally, what's the transition plan? Who is going to make the next investment? Where is this technology going to go afterwards? Does it have the right team? So there's a lot of these factors that come together to make a successful scientific team and a successful technology into an actual meaningful, impactful product. So how does Patio help with ARPA-H programs? We support across the program lifecycle. From the very beginning, we partner with the PMs in the program design phase to identify opportunities and gaps. We do assessments, and then as the program moves forward to solicitation phase, who are the right performers, helping the PMs as the kickoff and early program performance phase happens through different regulatory pathways. And then as finally the programs and projects start moving towards transition and commercialization, we have other capabilities. We have a small business program we run. We do have a sprints and launchpad, and we do have entrepreneur and residence program. So we have a suite of different capabilities that can help performers and programs across its life cycle. How do we do that? One of the ways that we can provide these services to our performers and PMs is through our partnership intermediary agreements, by bringing this private sector expertise on board, whether it is for a strategic insight, a regulatory reimbursement expert, or the general commercialization experts who can sit with our PM, provide advice. We have entrepreneur in residence program, as I mentioned, SPIR, CTR program. We have, as I mentioned, transition mentors who help our program managers with broad commercialization related expertise, and they come from years and years of industry experience. Next. So as you might be more even interested, how can we help our performers? We bring in on board these industry experts, whether it is they are entrepreneurs in residence, helping with general strategy, or whether it is very subject matter experts with very specific expertise in regulatory reimbursement, user experience, user testing, and then we are adding capabilities, additional capabilities I'll talk about shortly. But most importantly is that as you move towards the solicitation phase, and eventually some of you hopefully towards the performance phase, is to use your program managers and their advisory team to help identify needs. We run needs assessments to help identify gaps. And then as needed, we can partner the teams with entrepreneur residents or other experts that need it. But the key point is work closely with your program manager team, and they can reach out to us and we can initiate these different types of capabilities. I wanted to give a shout out also, as I mentioned, to our EIR program. We bring on board really amazing entrepreneurs in residence who have years and years of experience, and whether it is regulatory, like Kwame from years being at FDA, or Renee, who is a HEOR reimbursement expert. Just overall, they become almost fractional executives as part of the performer. And as performers get closer to commercialization or transition, we can bring on board these EIRs when the timing is right to help really with the next plan for the next phase for the performers. I also wanted to give a shameless shout out to our SPIR program. ARPA-H has a SPIR program. We have both phase 1 and phase 2, and we can fund up to $600K or $3.5 million in each of these programs. The reason I mention this may become interesting for some of the performers. We also have fast track and direct to phase 2 options. And these come also not just with the capital, but other support services that comes with our SPIR program. We're also prototyping other ideas. And one of the other ways that we can help our performers is navigating the health ecosystem. ARPA-H is a health network that we envision can connect various stakeholders within our fragmented ecosystem together to create one network that covers, right now we have partners from all over the country, and they come from a wide different range of institutions, whether it's academic institutions, whether it is health systems, they are manufacturers, clinical trial specialists. So they have their wide range, and they also come from small businesses, large businesses. And the goal is that we can leverage this network to help our performers navigate this complex health ecosystem. And next. And the way we envision that is by organizing these partners in our network around these subnets. And these are some of the subnets that we envision. There'll be more, is around regulatory support, reimbursement support, clinical support, IVMV, manufacturing, UI, UX support, support around data, commercial and others. And why does this matter? The reason that we envision this will be very useful is that transition hurdles will become apparent as the performance phase get going, and there may not necessarily be a known right up front. And the other reason is we can take advantage of economies of scale. We can obtain better pricing. We can get priority. And then as we start developing these subnets, we can start developing and learning from these patterns that we developed and learn from the patterns of performers, and eventually improve the quality of these services by our continuous learning. We're also piloting, keyword piloting, a 24-month accelerator for later stage health solutions. This would include capital, but also mentorship from dedicated entrepreneurs and residents, other resources, landscape analysis, and other subject matter expertise. We would be using those subnets or cores that I mentioned before, and then access to potential customers, investor showcases, and other amazing capabilities. This is currently in pilot phase, but we hope that we can grow this into a capability as some of the performers will be graduating from the agency and they can take advantage of this amazing resource. Thank you for having me here. And again, we're here to partner with the performers and program managers to make sure that the technologies succeed and we accelerate better health outcomes for everyone. Please don't hesitate to reach out to me or your program manager's team as in the future as necessary. Thank you. Bye.
Thank you, Mariam, for the presentation, and Andrea before that. And I have just a couple of announcements before we break for lunch. First of all, you have heard from a small number of us this morning, including myself, Susan, Andrea, and Mariam. But I thank them very much, and I would like to thank also other members of the team who have made this program and this proposal possible. This includes our systems engineering and technical assistance experts, Jason Bono, Avital Percher, and Maxim Izvatovat. So if you're here, you can raise your hand so people know who you are. Business and financial management specialist Bonnie Meyer, who may not be in the room. I think she's outside, and our events and logistics team lead, Stacy Higgins, and our AV specialist, Ryan Kelly. So thank you all very much. Good afternoon, everyone. Over the lunch break, we worked through your questions, and some of them required more thought, some of them we believe we can answer now. So we're gonna start with those questions and then see if we can finish on time before the one-on-one meetings. So I will open up with one question and then Andrea will follow with another question and so on. So my first question is a really easy one. Will program slides and recording be made available? The answer is yes. We will be sharing slides from today as well as the recording, but please allow us some time. It may not be today or tomorrow.
The first question I have is, are the budgets for the solution summaries final? And the answer is no. It's okay if your budget changes from the solution summary to the final proposal.
Okay, the next question I have is, do all three use cases need to be addressed in a single proposal? And we had three tracks.
So we don't have three use cases. There will be use cases within those tracks. And then as the solicitation indicates, there will be two use cases for the first phase, and then additional two use cases per TA2 proposal for phase 2. Does it answer the question?
So it sounds like, as I heard you say that, you do have to have all use cases eventually, but not for the first phase. Is that correct? Correct.
You don't have to submit to any of those tracks. You can submit a completely different track, like, any other track other than the two radiology and one EHR track that we mentioned. So I'm not clear if that's what you're
Can you
asking.
reread the question? Because I thought the question was about the use cases.
Yes, but it says, do all three use cases need to be addressed in a single proposal? And the answer is that in the first phase, you need to have two use cases. And going to the second phase, you need to add two more per TA2 proposal.
For TA2 proposal.
Yes.
What about for TA1 and 3?
So TA1, they're really going to be developing ground truth, surrogate ground truth extraction methods, either for those three tracks. So be as open as possible, and then they will be working with the TA2 proposer's use case to extract the surrogate ground truth for that one.
All right, next question. How filled out or complete does the BOE need to be for the solution summary? So in Appendix A, which is the solution summary template, Section 5 has a table. Fill out that table. That is all we need.
The next question is, since the surrogate ground truth models are also data-driven, do we need to monitor shift? And yes, there might be a danger that the data used for generating the surrogate ground truth also experiences some shift. Maybe it's extracted from, part of it is extracted from the EHR, and the EHR has been updated, or there has been a shift. So you do need to take that into consideration when you're generating the surrogate ground truth.
All right, I do want to go back and clarify the last answer I gave. So you need to fill out the table. If you are proposing to multiple TAs, it's one table per TA. Just to clarify. My next question here is, how many individual TA proposals or multi-TA proposals are expected to be awarded? I don't know. Awards are going to depend on quality of the proposals we get and the funding that we have available. So I'm not sure on the number of awards at this time.
Okay. Next question is, how can a model autocorrect when FDA doesn't allow for that? Is that part of PCCP? So for the duration of the program, there is no requirement that those tools be used in clinical management. So during the program, if your system is not being used for clinical management, is not used in clinical decisions, then of course there is no FDA involvement. But we would like transition to the clinic, and at that point, if a company is, for example, using the tools developed through this program for their FDA submission, yes, then they would be using the PCCP predetermined change control plan process of the FDA to submit their device if they want these tools to be used.
All right, next question is, how can academic sites subcontract non-US based companies and what conditions must be met? So we can't dictate how you arrange your subcontracting. You can, from our perspective, you would subcontract with them the same way you would a US based entity. But the details of that would have to be worked out between you and that entity. As far as conditions to be met, I mean, please don't go out and find a sub performer from North Korea. We'd appreciate that. But, short of something like that, we don't have a specific list of requirements for a non-US based entity to participate.
So a paraphrase question is, must we use existing models already in clinic, or can we train our own model? So there's no requirement that the AI DSTs, decision support tools in this program need to be already in clinical use. But as I mentioned, the purpose of the program was not to develop those tools. The purpose of the program is to do monitoring and then the automated updates and so on. So we very strongly encourage you to have something that is based on a validated clinical performance that you or your collaborator or somebody else has developed. Because again, the purpose is not to develop those tools. But if during the program duration, there are abilities or chances to improve those models, those are welcome.
Right, if a performer integrates TAs 1, 2, and 3, are they encouraged to collaborate with other performers? Yes.
Because our, maybe let me just compliment them. Because all of our ARPA-H programs are structured that way. So it is not that one performer is just doing something by themselves while others are also working on parallel tracks. So we do encourage cooperation and working together, even if a performer has an alignment of multiple TAs. Do you have a view on including generative AI as a use case? So the decision support tools that we are envisioning are based on predictive models. So as a use case, the generative AI is out of scope, but it doesn't mean that generative AI does not have use in this program. For example, in TA3, we mentioned bidirectional communication between the model and the clinician. So that communication, for example, can leverage generative AI tools, and you can think of other examples, but as a use case, generative AI is out of scope.
Can we partner with large companies? Yes.
If one proposal addresses multiple TAs, would ARPA-H award all TAs, or is it possible that subset of the proposed TAs be awarded? Yes, if you have proposed multiple TAs, it's possible that ARPA-H partially funds a subset of your proposal.
What is the expected number of co-PIs or partners for each proposal? Any numbers or recommended range? So we're not going to dictate how you set up your team, with the exception of, there should be one PI, a main PI who is, handling all of, the integrating of your team. But other than that, how you structure the rest of your team is up to you. We do expect that how you structure your team makes sense for your proposed solution and is justified in your full budget.
Requirement to release all IP with awards appears to be directly at odds with follow-on investment. Can you address apparent contradiction? So we encourage all proposers to consider business models that rely on open source or open core. We do note that this is desired, not required, and that proposers who wish to submit ideas of proprietary tools are welcome. But we, again, strongly encourage you to consider models that rely on open source. So although you have made that source open, there would still be a lot of business opportunities for you to commercialize that in ways that are not available in what you make publicly available. Yes.
When you refer to model source code, you really mean the model weights, right? I mean, model source code is, I don't understand.
Yeah, so again, maybe the language, and I don't know if I said model source code, I hope I did not. I mean source code. So the model, the AI decision tools that you use in the program, they can be kept proprietary if they are not developed with the contract from ARPA-H. What I mean is the tools that you develop for, let's say, monitoring the performance or for doing an automated update. So your decision support tool can be, again, proprietary, but those tools that you develop, we encourage you to make them open source.
So this next question is quoting the following from the solicitation. If you propose to TA4, you cannot submit to TAs 1 through 3. And the question is for us to please define you. So we are talking in general about organizations, but also keep in mind that an individual, because the reason for the restriction on the crosswork is to avoid conflicts of interest. So an individual also cannot be on for example, on a TA4 team and be on a TA1 through 3 team, because that presents a conflict of interest. So our intent here is to make sure that we're separating those performers. So when we say you, and this will be clarified in the final solicitation when it comes out, we are talking about organizations, but we also are going to make sure that you don't have individuals on your teams that are proposed across both of those.
What is the expected number of co-PIs or partners for each proposals? Any numbers or recommendations? So there is no recommended number or limit of co-PIs or partners. It's expected that the number of collaborators makes sense and is justified in the budget. But as we described in the solicitation, for example, TA1 performers need to have a minimum number of clinical sites or hospitals that they are working with. And of course, the larger the minimum number, I think in the first phase is like 3, but the larger that number is, of course, you can establish the generalizability and the performance or the chance, I would say, how widely applicable that is, will be larger.
Prior awards seem to indicate preference for finding academic or start primes. Is there a preference for prime organizations in this solicitation? No, and I will say as an agency, we don't have a preference. We are selecting based on the proposals that present us with the best solutions.
Will adding tech transfer deployment of proposed work to hospitals increase the chances? I guess it's meant the increased chance of being awarded. Having established tech transfer partners can be a plus, but it's not a requirement of the program.
To what extent should proposals be combined for teaming? For example, if there are different entities focused on different tracks but planning to work together, should they submit separate proposals but reference each other? That is entirely up to you. Just make sure that when you submit your proposal, you are able to demonstrate that the team you are proposing has all of the capabilities necessary to complete that work. So if you need to partner with someone in order to make that happen, then, that's where you need to consider partnering, but we're not going to dictate your business decision to partner or keep things separate.
Are models that continuously update during operation within scope as opposed to large discrete, large discrete updates. And by this, I understand not that the original decision support tool is already updatable, but that in TA2, the question is, should we develop an update strategy that is discrete or continuous? And I would say that that depends on the use case. It can be discrete. I mean, logically, I think you would have, I don't want to put any limits on it. So it can be both discrete or continuously adapting. You're done. Okay. So do open source program deliverables allow compiled runtime proprietary algorithms? Yes. So you can have an open source, but within it, you're calling a proprietary runtime model or algorithm, and that's certainly fine. Actually, I'm also done with the answers that we have prepared, but we can open it up for questions maybe for 4 minutes, because the first one-on-one session is at 3 minutes. So just 3 minutes.
Thank you so much. I was just wondering if you could clarify that the allocations of individuals not be able to cross TAs. I think we have some questions about, for example, Chicago. That's an organizational level, but 3 people from Chicago not be able to go across TAs or different organizations. So can you just clarify what you mean by individuals versus organizations, and then kind of how they split by TAs?
Right, so organizations that receive an award for TA4 or for TA5 cannot receive an award for any other TA. Individuals, if they are on an award for TA4 or TA5, cannot also be on an award for any other TA, because that creates a conflict of interest for that organization and for the individual.
Can you just clarify? Can you clarify by organization? Do you mean like an employer or kind of research group?
We are looking at your UEI in SAM defines what your organization or what your entity is.
I have 2 questions, but yeah, you can do the second one. So the first one is on TA1. For TA2, I understand you would like to improve the existing decision tools, but in TA1, can we involve another new AI to just help on TA1? That's my first thing. And the second question is, when you do the summary proposal for TA1, there's a phase 1 is 3 institutions, and then phase 2 is at 6 institutions. But do I have to show that we have 6 institutions from the beginning and in the summary proposal level, that we have that collaborator in up to 6?
For your first question, again, the purpose of the program is not to develop new decision support tools. So, I mean, if you are in TA1, if you have a proposal for TA1, it is really to help assess the performance of a decision support tool that already exists. I mean, it can be in clinical use or not in clinical use. So if I understood your question correctly, I would say no to your first question.
Just pre-processing of data. Like, it's not going to be a predictive model AI, but it's just like pre-processing.
Yeah, I'm not able to give more details. I think we have to see what you have. For your second question about 3, 3 sites for phase one and 6 in phase two. If you have already lined up all of your 6 or more clinical sites at the beginning of the program, of course, it might be a good thing to have, but you don't have to have all 6 identified at the beginning.
I think we're at time.
Yeah, we're gonna have to cut off so that we can move to the next. If you have additional questions, you can still write them down, drop them out at the table, and we'll answer them in writing, and we'll post those answers. One announcement I do want to make before we break. I want to put a plug in for our Doing Business with ARPA-H Industry Day that's scheduled to be held on November 13th. It will be 100% virtual. If you go to the ARPA-H site under the events page, you'll find the information and how to register. Registration will close on November 8th, but it could close sooner if we max out registrants. So if you're interested, please register early. There will be both large group presentations and interactive breakout sessions. So please take a look at that if you're interested.
Thank you, everyone. And this concludes the virtual part of the proposals day.